So we have over 650 different partners that we collaborate with, people in companies ranging from Autodesk, SolidWorks, and Siemens, all the way down to startups that are just kind of getting the ball rolling. So regardless of what your company size is or where you're at in your company's path forward, we try to provide solutions that can work for you on both a large scale or a small scale. So we have 4 SDKs that we provide. We have Hoops Exchange, Hoops Visualize, Hoops Communicator, which we'll actually be spending a lot of time talking about today, and also Hoops Publish. Hoops Communicator is a graphics engine that's designed for web browsers. So with this SDK, you can actually quickly load massive models with client-side and server-side rendering. Client-side and server-side rendering are actually some topics that we're going to be covering today, what they mean and what they actually do. And also, Hoops Communicator is very versatile. So whether you're in building and manufacturing or robotics, PLM, regardless of what industry you might be in, Hoops Communicator is versatile enough to provide a solution to you regardless of your industry. So a few components of Hoops Communicator that I'd like to briefly give you an overview about. We have the authoring library, which is made to import custom or proprietary data into Hoops Communicator. We also have Hoops Converter, which is a built-in executable within the Hoops Communicator download. So if you'd like to read in standard file formats, standard CAD file formats, you can do that and interact or transmit that data to Hoops Communicator and ultimately view it in a browser. There's also a server component, which we're going to spend a little bit of time talking about as well in this webinar. And ultimately, all of that leads to your end user's client application. So we're going to kind of cover each step of this phase throughout the tutorial. So now that we've done a little bit of background about TechSoft 3D and you have a little bit of guidance as to how this webinar is going to go, let's get into our first developer question. So the first question is, what is the Hoops server and what is the Streamcast server? And do I need either for my application? So this is actually a question that I had as well when I was starting to read some of the documentation. Hoops server and Streamcast server were kind of words that I found I sort of found within a lot of different documents that I was reading. So I was really curious as to what those words actually meant. So the Streamcast server essentially facilitates your model data. So if you have an application where you need to stream data to a web browser in order to view your model, you're going to have instances of Streamcast servers. So each model that you open within your browser is going to have a dedicated Streamcast server that will stream that model data as it's requested from your client application. So if you open up 6 different models within your browser, you're going to have 6 different instances of Streamcast servers. So these are one-to-one relationships. So each model gets one Streamcast instance. So in the case where you'd like to be able to actually open multiple models at the same time and be able to view them, you're going to actually need the Hoops server to be able to facilitate all of those different Streamcast instances. Because as I mentioned previously, Streamcast instances on their own are one-to-one relationships. So in order to manage having multiple running at the same time, you're going to need a Hoops server running for you. So your Hoops server might start out looking something like this. If you have 6 different models open, you're going to have 6 different Streamcast instances running. Then you can actually close different models or close different tabs within your browser. And so your Hoops server might look something like this. So as you can see, our 2 Streamcast instances were removed that we closed down, and our Hoops server is still monitoring and maintaining the 4 Streamcast instances that we have left. Additionally, you can open up a different model, and then your Hoops server might look something like this with a brand new Streamcast instance that is dedicated to the new model that you opened. So to drive this point home, we can actually see this in real time through a demonstration. So I'm going to swap the screens that you see and go ahead and share this screen. So I'm going to open, so I have Hoops Communicator 2021 downloaded, and within that folder, I'm going to go to Quick Start, and then I'm going to run this start server.bat file. So now that this file is running, I can actually go into my browser and go to localhost 1180, and I'm going to close this developer window. That'll be something that we get to here in a little bit. But so this is the page that opens when you run that start server.bat file. So as you can see, we successfully started Hoops Communicator, and now we just have essentially an empty terminal. This terminal is essentially going to show you what is going on within your Hoops server. So you can think of this entire terminal as your Hoops server, and you're going to see actually as we open up different models, you'll see how your Hoops server might look. So I'm going to go ahead and open up this model and go back to my terminal, and I can actually see that a new Stream Cache instance was spawned that ends with the ID of 818 and is now ready to stream, which essentially means that I can interact with this model in my browser. Additionally, if I were to open up another model, I can go back to my terminal, and this is what my Hoops server looks like. It now has 2 Stream Cache instances within it. This latest model that we open is now ready to stream, and I can interact. And I'll go ahead and open one more. And as you could probably guess, you'll see one more Stream Cache instance that's spawned and ready to stream. So I can now actually look and see the different IDs of Stream Cache instance that I have. And I can see this middle Stream Cache instance that ends in 5D6. So I can actually close that. I can close that model, and I should hopefully see within my Hoops server that I should see some type of reaction, like the server has, or the Stream Cache instance is now gone, or something that alerts me to say that that Stream Cache instance is no longer active. So I'll go ahead and close that one. And we can now see that the Stream Cache instance ending in 5D6 has now died. So this is essentially your Hoops server managing all of these Stream Cache instances. And as you can see, there's one Stream Cache instance that's generated for each of the models that we open up. So I'm going to swap back to the presentation really quickly. So to answer the question, Stream Cache, your Stream Cache server, you only need a Stream Cache server if you're streaming data to your client application. So if you're dealing with an application that doesn't require streaming, you actually don't need a Stream Cache instance or a Stream Cache server. Likewise, the Hoops server, you don't need a Hoops server unless you'd like to have an application where you can actually open up multiple models at the same time. Additionally, the Hoops server is more of a quick way to get started opening multiple instances at the same time. Again, if you don't need that within your application, you don't need the Hoops server. And additionally, if you need some type of other use case, you can actually build your own version of a Hoops server. So if this Hoops server as it is doesn't quite suit the needs that you have, you can actually build your own. So again, the Hoops server is also not needed depending on what your application is calling for. So we can go ahead and get straight to the next question. What is the difference between each file format? So as I mentioned in the previous question, there are some instances where you might be streaming data. And if you're streaming data, you need a Stream Cache instance. If you're not streaming data, then you don't need a Stream Cache instance. And we have different file formats that, that correlate to each of those use cases. So the first use case is when we're streaming data. So we're going to use an SCZ file format. So this file format, as I mentioned, is designed for streaming data. When you convert your CAD model to an SCZ file, it actually creates a singular SCZ file. We have some legacy file formats that will result in multiple files that get generated. However, the SCZ file format results in a singular file, which is great for server storage. So you only have one file that's linked to one CAD model. You don't have multiple files linking to a singular CAD model. So great for server storage. This file format comes in two different flavors. So you have compressed SCZ and uncompressed SCZ. So compressed SCZ is great for small models. There is a, it's great for small models. So there is a compression step that has to happen before it can be uploaded to your server. However, before that data can be streamed for viewing, there needs to be a decompression step. Now, this decompression step can take quite a bit of time if you're working with very large models. So therefore, due to this decompression step, the compressed SCZ isn't recommended for large models or large data situations. If you do have a large model that you need to stream and you would still like to use the SCZ file format, we have the uncompressed SCZ file format. So although the name says uncompressed SCZ, there is still a little bit of compression that happens when this uncompressed SCZ is happening. However, this file format allows for the server to randomly access information and data from the file without needing to go through that decompression step. So this file format allows for very quick streaming. So if you have large file formats, this lack of having that decompression step makes this a great file format to choose. However, if you have a restriction with how much storage you have within your server, this uncompressed SCZ is going to be a little bit bigger than your compressed SCZ. So that might be a limitation or drawback of using the uncompressed SCZ. So as I mentioned previously in the presentation, we have an executable, a converter executable that can actually take your CAD models and convert them into whatever file format you might need in order to interact with Hoops Communicator. So there's a few command line arguments that are necessary in order to generate your new file. So we're going to talk a little bit about what each of these commands mean. So to start out with, we have the converter executable file location. So this is always going to be at the start of your command. Next, you're going to have the name and directory of the input. And this input is actually going to be your CAD model. So the CAD model that you're trying to convert, you're going to give the directory along with the file name of that. Next, we have the create SCZ argument, and we're going to set that to true. This just specifies the type of file that we'd like to create. Next, we have this SC set editable. We're going to set that to false. And the reason that we need this command, or excuse me, need this argument is because if it's set to true, which it's set to true by default, an additional uncompressed copy of your file will be saved with your conversion, and that will essentially cause your file or your resulting file to double. So we don't need that additional uncompressed copy to be saved with us. So we're going to set this editable to false. The last argument that you're going to have is this output, and this is essentially where you just specify the output directory that you'd like your file to be saved to, along with the file name. So that's to generate a compressed SCZ. And the only difference between compressed and uncompressed is within this uncompressed, within these command line arguments, we have compressed SCZ, and we're going to set that to false. And I'm sure you could guess we're setting this to false because for the uncompressed SCZ, we don't want to compress that file. So we're going to go ahead and set that to false. So we can actually see this in action through another demonstration. I'm going to share this screen and let's see. Okay, so within, again, within Hoops Communicator, I mentioned that there's an executable that you can run to convert these files. So within authoring converter example, there's a sample.bat file that will actually show you how to convert to specific file formats. So this is essentially an example template showing you how to do exactly what we're trying to do right now. So based on that sample.bat file, I've created my own file called sample demonstration. So within this file, I'm actually going to comment this out. We're not quite ready for that. So I'm going to uncomment this generate compressed SCZ and generate uncompressed SCZ. So as you can see, we have our converter directory. We have the file location of the model that we'd like to convert. We have create SCZ, setting that to true. We're setting editable to false. And then we have our output location. So we're going to save this to a demonstration output folder, and we're going to label our compressed SCZ file to compressed SCZ. And the only difference between these two these two arguments or commands, I should say, again, we're going to set SCZ to, we're going to set compressed SCZ to false for our uncompressed version. And then we're going to just change the file name as well. So we're going to call our compressed SCZ, compressed SCZ, and our uncompressed SCZ. So I'm going to go ahead and save that. And I'll show you my demonstration output folder. As you can see, it's already, there's nothing in it as of now. So then when I run this batch file, we can see that it's loading the model that we specified. And now it's saving the SC model, so compressed SCZ, we can see that. And it will continue to run through, and hopefully in a little bit, we'll be able to see that the next version of this, which is essentially our uncompressed SCZ, will begin to load as well. So again, we're loading the model, so we went to our next command by now. And so once it's done loading the model, hopefully it will begin, it will finish saving. And this is taking a little bit longer than it typically does. So we might have a slight error, downside of running live demonstrations. Let's see. Okay, I'm actually going to kill this really quick and try that one more time. So we got our compressed SCZ, but our uncompressed, there was something wrong. So I'm going to open this up and make sure that I didn't add anything weird. Everything seems to look okay. So we're going to try one more time, and hopefully this works. So again, loading, currently saving. Okay, so now loading again for our second command. All right, and now it's, for some reason that loading took a little while the first time, but now it's saving. And so here in a little bit, our window should close, and that should signal that we've successfully converted each. All right, and so now we can check our demonstration output. And as you can see, we have our compressed SCZ and our uncompressed SCZ as well. You'll also take a note that our uncompressed is a little bit bigger than our compressed SCZ, which is something that we should have expected. So that ended up working out, thankfully. So I'll go ahead and switch back to our presentation. So we saw the file format that was used for streaming data. So now we're actually going to look at when you're not streaming data. And this is the SCS file, so file format. So again, made for when you're not streaming data, made for use cases without the server. Excuse me. Similar to the SCZ file format, it results in a single converted file. So it'll result in a single .scs file. It's directly readable by the hardware visual Hoops web viewer, and it greatly reduces application complexity because you're no longer having to streaming your data. The downside to this file format is that this file will need to be completely downloaded before the user can begin interacting with the model. However, it's great for small models because the download time versus streaming in that model data is almost negligible for small models. Another benefit of this SCS file format is that the first time the user downloads this file, it may take a little bit before they're able to interact with it. But in a lot of cases, the file will actually be saved to the browser's cache. So the next time that the user tries to open up this file, that file will already be downloaded and their interaction with it will be almost instantaneous. So similar to the SCZ file formats, we have a very similar command line argument structure. So we have the converter executable directory. We have our input specifier along with the model directory and the model name that we'd like to convert. We're going to set our output SCS. We're going to set this so that it knows what type of file that we're going to create. And then we're going to set our output directory as well. So I'll go ahead and show you what generating this file looks like. So I'll go ahead and open up our sample demonstration batch file, and I'll comment out this compressed SCZ and this uncompressed SCZ, and uncomment this generate SCS file. So as you can see again, converter directory, input specifier with our model location, and our output. So we're going to again save it to demonstration output, and we're going to label this as generated SCS. So we should expect to see very similar behavior as generating that SCZ file. Uh-oh, that closed a lot quicker than it normally does. Okay, so we're loading our model up. And then as you can see, we're saving the model generated SCS. So it's going through the process of converting, and so hopefully so now our window's closed, hopefully signaling that we've successfully converted. So now, as you can see, we have our generated SCS file. One thing that I noted, and I was supposed to ask my manager before this webinar, but I noticed that these file formats, the generated SCS and our compressed SCZ, are very close in size. I can't say that they'll always be that close in size, but that was actually a question that I had on my end. So I'll actually follow up with him and get an answer to my question. So I'm going to go back to the presentation. So that's a little bit about the different file formats that we have to offer. There are some legacy file formats that I didn't talk about within this webinar. So if you look online, you might see some other file formats that didn't get covered. However, these file formats aren't necessarily recommended for new applications. So I just didn't cover them within our talk today. So question 3 is relating to how is measurement handled within the Hoops web viewer? So there are 2 ways that measurement is handled within Hoops web viewer, and that's through BREP and tessellation. So BREP is a mathematical representation of your model. It's essentially nominal data. It's a perfect representation of your model. Like you couldn't even manufacture to the same degree that your model is represented in with BREP data. So your model has to be exported with BREP data. So from whatever CAD program you're using, you actually need to specify that you're exporting with BREP data. If that data isn't present within the Hoops web within that file, I'm sorry, then Hoops Web Viewer won't be able to generate that data on its own. So it needs to be present upon conversion. On the flip side of that, there's tessellation, which is essentially a triangle mesh that attempts to represent your BREP data. So it's a triangle mesh that essentially tries to form around the same curves and everything that you see within your model. So I'm going to share my screen again and give you another demonstration to hopefully give a better explanation about the difference between the two. So I'm going to go to, I'm going to start this server. And then I've actually made a couple files that have BREP data present and no BREP data present. So it's essentially just a tessellated model. I'll expand that. So I'll open this one and open this one. So we have two separate models. So this model is showing a tessellated model, and this model is showing a model with BREP data. So one clarification that I had to make was when you're viewing these models, they're both tessellated. So even if I zoom into my BREP, even though it looks very smooth, in order to show this within the Hoops Web Viewer, there are still triangles that are being generated to show your model. However, the resolution on this model is just a lot finer than what it is on this completely tessellated model. So there are a few different measurement operators that are present within the Hoops Web Viewer, such as measure angle between face, you have measure distance between face, measure edges, or point-to-point measurement. So as I mentioned previously, tessellation is just a triangle mesh. So there's no data relating to what's an edge versus what's a face, what's a surface. It's literally just a mesh of triangles. So these operators actually won't be available to you if you don't export your model with BREP data. So you can see that I'm hovering over this model, trying to use these different operators, and nothing's happening. However, on the side where there is BREP data present, if I switch to one of these, I can actually hover and I can see these different edges highlight. And so I can click on an edge and get things like the radius of the bottom of this vase and different information. On the tessellated model, as we already saw, we don't have that information present, so we can't use these operators. The only thing that we can actually use is point-to-point measurement. So I can click here and get essentially a distance between those 2 points. However, tessellation is very inaccurate. Again, it's just a triangle mesh trying to replicate what we see on this end. So even if I do point-to-point measurement, there's no guarantee that I'm actually getting the full diameter of the bottom of this surface. Additionally, since I'm using point-to-point measurement and this is a triangle mesh, what's actually happening is when I click, the Hoops Web Viewer is essentially just finding the closest triangle point to where I've clicked. So even though I think I might be clicking in one area, the next closest triangle might be slightly over, excuse me, might be slightly over. So there's no guarantee that I'm actually getting a real and accurate measurement from my point-to-point measurement. On the flip side, when you have BREP data present, rather than saving all of that BREP data with the converted model, on conversion, the converter actually runs an equation to get things like the circumference of, the outer rim of your vase, to get things like your radius. So these values are actually already calculated. So when you click on different surfaces, the Hoops Web Viewer is essentially just regurgitating information that it already knows. So it's not running calculations in real time or anything like that. it already has those calculations done and those values stored. So you know for sure that you're getting accurate measurements of your model, and your measurements are exactly what you expect them to be without error, unlike with the tessellated model. So I'm going to swap back to the PowerPoint once again. So that is essentially the two ways of measuring within Hoops Web Viewer. You have BREP data and you have tessellation. Tessellation, just to recap, only works with point-to-point measurement and is not extremely accurate. However, if you really need accuracy within your measurements, you'll need to export your CAD model with BREP data. So the next question is, how can I change the default measurement units within the Hoops Web Viewer? So as you probably could imagine, I have another demonstration for you. I'm just going to clean up some things on my side before I flip over. All right, so again, within the Hoops, within my communicator download, I'm going to go to my tutorials, basic app, and I'm going to run this start server.bat file. I'm going to close a few of these windows. And again, I'm going to go to localhost 1180. And this is essentially the default basic app. This is what you'll get out of the box. So you'll see a title along with a box that allows you to interact with a model. And then you'll see a few different operators that are available. You have things like orbit or select area. Now this measure and bounding box operator, I actually added myself, and the ability to switch units is something that I added myself. So what we're actually going to talk about is this functionality right here, being able to add different markups showing the radius and showing the length, and then being able to swap between inches and millimeters. So for this, I'm going to open up my developer window, and I'm going to run through a little bit of code with you. So within this code, there are a few things that I'd like to specifically highlight, and some of the rest I'm going to just kind of gloss over. So I'm not really going to talk about the HTML or anything like that to get these drop-down menus, but some of the key points about adding these measurements is what we're going to talk about. So when there's a mouse down event, we essentially get a selection based on the location where we clicked. From this selection, we're going to run this add measurement function. And within here, we're going to get a few characteristics like the face entity, the line entity, the node ID, and the position. We're then going to run a check to see if the node ID or the position is equal to null. And so this is essentially just checking to make sure if I'm clicking off of the model somewhere, that's not a valid selection. So we're just going to return out of here and not do anything. So if we are able to, if we actually click on something, we're actually going to get something called a unit multiplier. And so I'm going to add a breakpoint here and click somewhere on the model so we can talk a little bit about what a unit multiplier is. So I'm going to click on this line. Let's see. Live demonstrations once again. Let's go to measure and try to click. There we go. Okay. So, so we just clicked on an edge. And so now we've just gathered our unit multiplier. And so I'd like to actually print out what this unit multiplier value is. So our unit multiplier value is currently 1. And it should be noted that we're actually displaying in millimeters right now. So so that's something to keep in mind as I try to explain what a unit multiplier is. So just keep in mind that we're currently in millimeters and our unit multiplier is 1. So I'm going to swap back to this presentation. Okay, let me just double check. Okay, so you can see my presentation. So Here we go. So unit multipliers. So a unit multiplier is essentially how many millimeters are in one single unit of whatever unit is being displayed currently. So hopefully this will make more sense the more I talk about it. So if we are currently displaying inches on our screen, our unit multiplier is going to be 25.4 because there's 25.4 millimeters in a single inch. Additionally, if we're displaying in centimeters, our unit multiplier is going to be 10 because there are 10 millimeters in a single centimeter. And lastly, if we're displaying in millimeters like we currently are in the example, our unit multiplier is going to be 1 because there's 1 millimeter in 1 millimeter. So we'll go back to the example on the screen. And if unit multipliers still aren't quite making sense to you, hopefully as we go through this demonstration a little bit more, it'll make a little bit more sense to you. So the next thing that we're going to do is check to see if we've got a face entity or a line entity. And I'm pretty sure I selected on a line entity. So I expect my breakpoint to come into this if else statement. So now we're here. And once we get this, we get properties from our selection. And then we're going to feed that to add line measurement. And the only difference between this check here, the only difference between face entity and line entity and the conditional that we have, we're just calling different functions. So we're going to either add a face measurement or add a line measurement. And again, the only difference between those two is we're either using a radius or we're using a length. And so since we're working with a line measurement, we should expect our breakpoint to come in here. So I'll go ahead and skip over. And so as you can see, we're getting ready to set the text that we've seen from our previous markups as well. So we have length, colon, and then we have a string specifier. So we're going to get our length. So I'll go ahead and print out property.length. So that's 9.55. And we're going to divide that by our unit multiplier, which we already know is 1. So the length that we get, we should see something like length colon 9.55. And then within this string specifier, we're giving it the unit multiplier again so that it can be followed by the units that are currently being utilized. So we should see length colon 9.55 millimeters, for example. So I'll go ahead and skip over that. And so that's exactly what we see down here. So the next behavior that I wanted to talk about, and again, these unit multipliers are going to come back into the picture, is switching between millimeters and inches. So I'm going to go ahead and place a breakpoint right here, and I'm going to try to switch to inches. So we just hit our breakpoint. So our first check is to see, are we switching from 2 millimeters or are we switching to inches? So we're no longer switching to millimeters. So that is why we came into this conditional. And then within this conditional, we're going to run through each of the markups that we have and try to get the current measurement. So this for loop essentially runs through each markup, and the way that they're placed is based on the order in which I placed them on the model. So I believe that I placed this length 23 millimeters first. So I think that I should expect to see this being my first measurement. So I'll go ahead and step over and I'll go and print out my current measurement dot length. Okay, it is 23. So we're dealing currently with this markup right here. So from our current measurement, we're going to get our unit multiplier, and we're essentially going to do a sanity check. So if our current unit multiplier is 1, we know that we're dealing with millimeters. So we're essentially just checking to see if we're currently in millimeters trying to go to inches. If this was 25.4, then that will mean that we're already in inches and trying to go to inches, which isn't a valid selection, so we just do nothing. So since we have a valid selection, since we know our unit multiplier is 1, we're going to go ahead and go in that if statement. And then we're going to set our unit multiplier to 25.4. We're then going to check to see if we're measuring a line item or not. If we're not, we're going to use radius. If we are, then we're going to use length. And since we know that this is the markup that we're changing, we already know that we're measuring in length. So we should expect to go into this. And so similar to how we saw previously, we have length colon and then a string specifier, which is just going to get the current measurement.length. And then it's going to divide it by our unit multiplier. And so our unit multiplier, as we already know, because we just set it, but I'll just go ahead and show you, current measurement.unit multiplier is 25.4. So we should expect to see a number lower than 1, followed by our the current unit that we're converting to. So if I go ahead and just run this, we can see that our lengths have now changed, our lengths and our radius as well. So we see that that 23 divided by that 25.4 results in a number that is 0.91. So we were successfully able to convert. One thing that I'd like to show you, however, is when we switch back to millimeters, again, the for loop runs based on the placement of these markups. So I placed this one first. So I'm just going to assume that we're talking about this markup as we're entering into this breakpoint. What I wanted to actually point out is the current measurement.length. Current measurement.length. So as you can see, the current measurement.length is still that original 23. And that is because within Hoops Communicator, regardless of what your unit multiplier is or whatever's being displayed on the screen, this original length is always going to stay the same. And that's because we don't convert between millimeters and then back to inches and then to centimeters, because there would be some floating point loss. And eventually, as you continue to switch between different units, your value would actually change. So we actually leave this measurement exactly the same and we don't touch it so that you can get an accurate representation of that number every time you switch back and forth. So I just wanted to point that out. So as you're developing, just keep that in mind. So as you can see, we swap back to length of 23, our radius and everything, we're able to swap back and forth as expected. So I'm going to swap back to the presentation again and clean up some stuff on my end. All right, so hopefully that was able to answer a little bit of how to swap between different measurements and units within Hoops web viewer. I can actually send out that code or anything if you so desire. So our last and final question is, when will I need to use SSR and how does it differ from CSR? So server-side rendering or SSR versus client-side rendering or CSR. With server-side rendering, rendering is handled by your server, which means that it requires a GPU to be present on the server to handle all of the rendering of the models that you're going to be ultimately sending to your client devices. This implementation can be a little bit more expensive than client-side rendering. However, if you're working with devices that range from low-powered devices to high-powered devices, or if you're working with very large data sets, server-side rendering is a good option because regardless of if somebody is trying to look at a model on their phone or they're looking at it on a high-powered engineering laptop, you can guarantee that they'll have a timely interaction because your dedicated server GPU is handling all of the rendering. This is also a good option or good implementation if security of your CAD or security of your models is an issue. With server-side rendering, since all of the rendering is happening on the server actually just sends an image to your client device. So rather than a full tessellated model, your client device is just getting an image. So there's nothing that can be copied or anything like that when using server-side rendering. So if security is important to you, then server-side rendering might be a good option to explore. On the flip side, you have client-side rendering. In this implementation, all of the rendering is happening on the client device, which means that there's no GPU necessary on your server. This rendering is limited by your client device. So if you are using like a smartphone, you will have a slower experience than if you were rendering that same model on like a high-powered engineering laptop. This implementation is less expensive than server-side rendering. However, since it's less expensive than server-side rendering and is more scalable than server-side rendering, it's actually recommended for most of our partner applications. This implementation, however, will give your client device a fully tessellated model, which will be a much clearer model. Sometimes with server-side rendering, the image can look a little bit fuzzy. With client-side rendering, you won't get that. And so that makes client-side rendering great for if you know that you're going to be working with high-powered client devices, or if you're working with smaller models, or if that interaction and that immediate need for instant interaction isn't necessarily needed, then client-side rendering is a great option to explore. So we've actually done a side-by-side comparison of server-side rendering versus client-side rendering, and I'll show you the result of that. So on the left, you have client-side rendering, and on the right-hand side, you have server-side rendering. So as you can see, and I should mention that both of these were run on an iPhone 11. So as you can see with server-side rendering, it took about 8 total seconds for that entire model to be ready to interact with on the iPhone 11. However, on the flip side, using CSR on an iPhone 11, it took about 1 minute and 10 seconds for that same model to be able to be interacted with. So when dealing with lower power devices, since you have a dedicated GPU on your server, server-side rendering can be a very useful implementation depending on the requirements of your application. So that essentially is the top 5 questions that we have for the Hoops web platform. If you're interested in learning any more about some of the topics that were talked about today, we have a link to the developer zone, which you can actually download that same communicator package that I was using to demonstrate all of these examples. We have a link to the TechSoft 3D YouTube page as well. On there, we have links to, we have videos of previous webinars, we have tutorials, and just a wealth of video information on our YouTube page. We also have the TechSoft 3D forum, which Gabe is going to talk a little bit more about once I'm finished up here. And we also have links to the Hoops web platform overview if you just need some more information. And then as far as some of the topics that we talked about today specifically, we have links to the Streamcache and Hoops server overview. We have links to the unit multiplier. If that's still a little bit fuzzy, we have a link for that. More information about Hoops Converter and more information about measurement in Hoops Communicator. So with that all being said, thank you so much for joining me in this webinar, and thank you so much for being my guinea pigs. This was my first webinar for TechSoft 3D, so thank you so much, and I hope you enjoyed. And Gabe, here's the community slide if you'd like to take over.
Thank you. And thanks for that wonderful presentation. I just wanted to let you guys know, if you're not already aware, that we do have the community that Ricky mentioned. It's forums, and you'll be able to get today's recording from there. In addition, it's just a place for you to talk about TechSoft products, SDKs, receive any help if you need any, if you get stuck and you're on an evaluation. That's a great place to kind of stop and get answers to those questions. And I will post the link to where the recording for this will be. And if you have any questions after the presentation regarding anything covered today, you can post them in that thread as well. Um, and without any further ado, it doesn't look like we have any questions in the chat. Ricky, is there anything else you wanted to mention before I go ahead and wrap things up?
On my end, the links I can actually post along with the webinar upload so that you can have access to all of those links and we can get those out to you.
All right. Well, thank you, Ricky, and thanks for everyone for joining us today. I went ahead and posted the link to where the recording will be in the chat. Again, if you haven't already, be sure to sign up for the community and join the discussion. Again, a big thank you to Ricky for the informative presentation, and thanks to all of you who joined us today. At the end of this event, there will be a feedback survey for you guys to fill out. Please participate if you can. That helps us make better content for everyone in the future. It was wonderful hosting this event today, and we will see you again next time.